Hello and welcome everyone. Thank you for joining us today. My name is Vinod Iyengar. I'm the VP of Product and Marketing at H2O.ai. Love to start off by introducing our speaker, but before doing that, I want to do a quick sound check. In the chat or questions section on BrightTech, if you can just let us know if my voice is coming through fine, just by yay or yes, something. That'll help us make sure that we are doing okay. All right, looks like we are doing okay. So I'm going to jump in ahead. So let me introduce our speaker today. Marc Stein is the founder and CEO of Underwrite.ai. Underwrite.ai applies advances in artificial intelligence derived from genomics and particle physics to provide lenders with nonlinear dynamic models of credit risk, which radically outperform traditional approaches. Without further ado, I would like to hand it over to Marc.
Thanks, Vinod, and thanks everybody in the audience for being with us today. I really wanted to talk today about why machine learning is really critical in addressing some of the most serious and heretofore fairly intractable problems that we have. And, you know, a couple of really good examples of that are a problem of credit availability throughout the world, particularly in underserved markets and underserved communities, and also the question of cancer prediction through genomics. And you know, both of those have a commonality, and that both are an inherently nonlinear problem being addressed with linear solutions. So I wanted to go into a bit more detail about what's wrong with the current model of consumer credit and the disadvantages that it places people throughout the world to, and talk about how tools like H2O and DAI can help democratize the availability of credit throughout the world. So what's traditional credit underwriting and why is it a problem? Well, the current model of consumer credit that we use today was developed at Stanford Research Institute in the late 50s by a couple of gentlemen named Fair and Isaac. And they then left SRI and started a company called the Fair Isaac Corporation, which is today known as FICO. And their model of consumer credit risk has been the dominant model in the world since that time. And it's based upon predicting the future occurrence of credit repayment by analyzing the past performance of credit repayment. So this is the construction of the FICO score itself. And you can see that it has 5 basic inputs to determine your FICO score. Now, once the FICO score is derived, the lender typically constructs what's called a scorecard or a rule set around 4 basic attributes: the FICO score itself, the debt-to-income ratio, trade line performance such as late trades, and an inquiry count. How many times within a given period of time have you requested credit? So the way that 99.9% of consumer credit underwriting works in the United States is that you apply an application, and the first thing that they do is pull a credit bureau, and they look at your debt-to-income ratio. And if the debt-to-income ratio is above a certain threshold, typically something like 45%, they decline you. If you have late trades, such as a 60-day late trade on your file, they decline you. If you have more than a certain number of inquiries, typically 4 and 6 months or 6 and 6 months, you're declined. Now, if you're not declined for any of those scorecard rules, the next thing that happens is they look at your FICO score, and the FICO score will determine the rate that you pay, or it's the final determinant of getting the loan. So if you have a FICO score below the threshold of the lender, you'll be declined regardless of the other rule tests. So lenders will typically decline at 680, some at 660, some as low as 600. Then you have subprime lenders that go quite low in terms of FICO score. But that's basically what credit underwriting today looks like. So overall, this works pretty well. For the 50% of the population that has the FICO score at or above 700. This is what's known in the credit world as the prime lending space, scores of 700 and higher. And the reason why lenders are comfortable with this is twofold. A score of 700 has largely de-risked the population. So if you only loan to people with scores at or above 700, your risk is going to be readily understandable and predictable as a portfolio. The problem with this model is that the further you get from FICO 700 in the downward trajectory, the less efficacy the model has. So when you get into subprime lending, your basic model for underwriting is little better than a coin flip. The model is very biased towards lending in the prime space. The model that is in current use stops working entirely in the absence of a FICO score. Now, in the U.S. today, about 25% of the population has no FICO score. They're what's known as thin file consumers. They have a presence at the credit bureau, but they don't have enough credit activity for FICO to derive a score. One of the things that's going on in American society today is the percentage of people without a FICO score is growing. And the reason for that is we see people who don't have substantial credit background, recent immigrants, people who work in the gig economy, people who drive for Uber, for instance, are often excluded from credit availability because they're considered self-employed. People who are new to the workforce, recent graduate looking for their first job, is very likely to have a thin file. People who are paid their wages in cash are much less likely to have credit trade lines than people who are paid with direct deposit or paid through a payroll system. So this 25% of the population is actually trending upwards. So essentially, 50% of Americans have access to reasonably priced credit. That is, they can go to a lending club or Prosper, they can go to a credit union or their community bank, and will probably be able to get a reasonably priced loan. 25% of the population does not have access to those resources, and their availability to credit is through payday lenders, short-term installment lenders, check cashing services that are prohibitively expensive. 25% of the population has essentially no access to credit. So why does this problem exist? Well, the answer lies in the nature of the problem. we can divide problems into two general sets: linear problems and nonlinear problems. Linear problems tend to be simple problems and relatively easy to derive an answer to using a linear function. But most complex problems that we face are inherently nonlinear. Yet they're still approached, for the most part, with linear solutions. And I'll give you a good example of the difference between a linear and a nonlinear problem. If you imagine a physics experiment and you're riding a bicycle at 20 miles per hour and you throw a baseball at a velocity relative to yourself of 30 miles per hour, and the object of the experiment is to determine the combined velocity of the baseball. This is a classically linear problem, right? We're just going to sum the two forces. Now imagine that you repeat the experiment, but instead of using a baseball, you throw a paper airplane. Well, what had been a very simple problem of summing two forces is now a very complicated problem, because there are a great many forces that will impact the velocity of the paper airplane. So you've gone from the linear realm into the nonlinear realm. Well, credit in the 700 and above space is largely a linear problem. Credit outside of that space and credit for thin file consumers is a nonlinear problem. Yet lenders approach these problems with logistic and linear regression. And the reason for that is, as I had mentioned before about this typical scorecard, well, the scorecard has four primary attributes. It's relatively straightforward to construct a set of if-then rules with the permutations of four attributes. The problem is, if you need to cover all the permutations of 10 attributes, it becomes a very large rule set. So the basic structure is geared to simplifying the problem so that it can fit into a simple rule set. So this is a simple solution to a complex problem. If you want to solve for the full set of consumers instead of only those above FICO 700, you need more than four variables, and you need to look at combinatorial features. And this is where machine learning algorithms and tools like H2O and Driverless AI come into play, because they give us the ready ability to construct nonlinear solutions to nonlinear problems. One of the things that, when I originally started Underwrite, I was working on correlating genomic state in the form of an RNA microarray to prostate cancer probability. And the difficulty in doing that is that we needed to look at 50,000 inputs as a vector into the model. And at the time, there weren't really any tools that allowed us to feed in that type of vector. And this was before H2O went into beta. So we started constructing mechanisms for being able to support that kind of search space in machine learning, and creating AutoMLs that dealt with applying multiple algorithms to that search space. But today, it's rather simple to feed in a large variable set and model it in a nonlinear fashion using a tool like DAI.
Mark, a quick question here. It's an excellent point you make about looking at nonlinear problems, right? Could you, I know you mentioned that, if you had to go beyond solving this linear techniques, you want to use a lot of other variables. Can you talk a little bit about what kind of other variables that are available today, for example, outside the thin file data, the four that you talked about in the previous slide? What
Yeah.
other data is available?
When we're talking about credit, we receive a large number of variables from a credit bureau, right? So everyone is accustomed to looking at the bureau file as a FICO score and some summary data. But the credit bureaus actually make accessible thousands of variables about a consumer's credit. One of the things that we've known to be highly predictive is inquiry count, but it's not inquiry count in the traditional way. Most lenders have created a rule around if there are more than 6 inquiries in 6 months, they're going to decline the applicant. One of the things that we noticed early on is if an individual has applied for credit once a month for 6 months, that's one risk profile. If an applicant has applied for credit 4 times this week, that's a much worse risk profile. So whereas the inquiry count is very important, it isn't important or useful in the way that most lenders approach it. We need to view it as a time series, and what we're really looking for is the delta on the rate of inquiries, not the raw inquiry count. So in order to implement that, what you're looking at is the inquiry count for today, and for yesterday, and for last week, and for last month, and for the last quarter, etc., and build that as a time series. So that's one of the things that we do in our modeling process. There are a large number of attributes which are granular across time. So we're very interested in late payments, for instance, but it's a matter of when the late payment occurred, because the person who's had an excellent credit record, except they had a period of time in which they had a series of late payments, it's very difficult if that period of time was last month versus if it was 2 years ago. So when these things occur, need to be factored in, and the typical credit report doesn't really address those temporal factors very well. So that's a lot of the focus that we bring to the modeling process. When we wanted to create a model for thin file consumers, even though they're thin file consumers, we looked at 16,000 attributes for someone who doesn't have a FICO score. And from those 16,000 attributes, we initially did an analysis using information game theory to determine what has any predictive value out of the 16,000 and what doesn't. And from that process, we were able to derive 610 attributes that had a high predictive value. Those 610 attributes then get fed into DAI, and DAI then does feature engineering to start testing all of the original features and creating combined or clusters of features to test for predictive ability. And so essentially, much of the difficult work that we would traditionally have to do in creating and running the tests and building the ensembles necessary to deliver complex nonlinear models is automated through the DAI process. Does that address your question, Vinod?
Thank you. Yes,
Okay.
definitely. Thank you.
All right. So I wanted to show an example of how we can look at a problem such as credit modeling using DAI. So here's a good example. The current release of FICO is FICO 9. FICO 9 hasn't had a tremendous amount of take-up yet. The dominant model in use today is FICO 8. FICO 9 is a somewhat more advanced model because it has a more nuanced and intelligent view about medical debt. One of the problems with FICO 8 is that if you have a series of late payments around medical debt, that significantly dinged you for that deficit. The issue comes about when, let's say you have health insurance and you go into the hospital and you get a $250,000 bill. Well, the hospital sends it to your health insurance company, who doesn't pay it immediately. So the hospital then comes to you and sends you the bill. Well, you're never going to pay that bill, but it's still on your credit file. So for all the time that the insurance company is dickering over the bill with the hospital, you are showing this indebtedness. And that has caused a tremendous amount of financial disruption to people because it created an illusion of debt that isn't really very realistic. In that situation, you're not really going to pay the $250,000 bill. So what Fair Isaac did was to come up with a better system for dealing with that type of medical debt and differentiating between what's a realistic payment that you're in fact going to make and what is due to an insurance company mediated delay. FICO 9 also looks at things like rent payments and utility payments, which gives it better applicability to the wider swath of the market. So FICO 9 is actually, from a machine learning standpoint, a really good score. The area under the curve, or AUC, of FICO 9 is about 0.78. Typically, we see in production situations that the AUC of FICO 8 is between 0.66 and 0.68. So 0.78, if you've done this kind of modeling before, is quite good. When we build models at Underwrite.ai, we look for models to fall typically between 0.75 and 0.85 in area under the curve. So the AUC of FICO 9 is quite good for a generalized credit score in the U.S., but with the caveat that it only applies to 75% of U.S. consumers. So I wanted to kind of demonstrate what could you do with this if you had the same information that's available to FICO 9. And so we took a rather large credit set of attributes, and in this set we had 222 credit bureau attributes. We looked at a larger set and we found all the attributes that actually correlated to a loan outcome of a 60-day late within the file. So we took this set of data and we made sure that it just had one dependent variable, which is an outcome called good or bad. And basically good was that the loan did not have any 60-day lates during its its lifetime. We took that file and we divided it into 3 files. So we have a training file which has 313,000 records in it. We then set aside a hold file with 10,000 records to be outside of the training and validation process, and that is our final test on the model. The remaining, which is 30% of what's left when you take out the 10,000 files for hold, is a validation set. So what we did here is we loaded this up into DAI, and we dropped one column, which was the charge-off indicator, because that will track with our outcome. And we put in the validation set and the test set. And we started out with the initial settings of 8 for accuracy, 5 for time, and 5 for interpretability. So these are dials that you can set in DAI. The greater the accuracy that you set, that's going to impact how long the model is going to take to build. The time setting will change the amount of time that it takes for the modeling process. You can increase the amount of time to run more experiments and have more granular control. You can decrease the amount of time to make it run faster. Interpretability is an important setting because when you are dealing with something like consumer lending, really anywhere in the US or the EU or Canada today, you have a requirement to explain your decision. And that requirement is not just to explain how the model works, but you have to explain why you came up with a given decision. We have something in the US called the Fair Credit Reporting Act. And basically what the Fair Credit Reporting Act says is that if you are going to loan someone money and they give you permission to view their credit file, then you have a period of time in which you will determine whether to give them a loan or not. And within that time period, you either need to make them a firm offer of credit, or you need to explain to them why you can't loan them money. And the explanation of why you can't is called an adverse action notice. So typically you have 30 or 60 or 90 days, depending upon your industry, to comply with that rule. So black box underwriting is not legal in the United States, Canada, or now in the EU under GDPR. You can't use something like a deep learning network, which is inherently not transparent or explainable. You have to use techniques which are fully explainable. The interpretability flag in DAI is essentially a setting that controls the complexity of the model in terms of its interpretability. So for instance, I might be able to increase the accuracy of a model by turning the interpretability down and thus causing the model to look at a greater, or the process to look at a greater number of pipelines, do more extensive feature evolution, and build a much more complex model. But the expense of that is if I set it too low, I'm not going to be able to explain my model sufficiently to a regulator or a borrower, and I'm no longer going to comply with the regs. So you use those experimental settings to fine-tune your inputs. You have expert settings that allow you more granular control. But basically, this takes you to a point where it's ready to begin the machine learning process. And you can see that with the settings, it's going to do up to 103 iterations of feature evolution, and it's going to stop after 10 iterations without improvement. So these are things that you can override with the settings we were just discussing. So what this is going to do when we hit launch experiment is it's going to do feature engineering to start taking these 222 attributes and testing them for predictive value, and then start clustering them together to have combined features and test those for value. So keep in mind what the result was for FICO 9, and then when we finish running this DAI model, you can see without even doing any tweaking, we basically created a model that covers 100% of U.S. consumers and significantly outperforms FICO 9. So the DAI model is returning a area under the curve of 0.81865. What you see on the screen here is 8124 because that is the AUC of the validation set. But if you look down here in the lower right-hand corner, you'll see that we held out those 10,000 records as a test set to be outside of the validation and training scope. And actually, the test set had a higher AUC of 0.81865. So in theory, it isn't really necessary to have a discrete holdout set, but I find that as a practice, I have a lot more confidence in results when I have a set that is completely blind to the training and validation sets, because it's an accurate proxy of new data that's never been seen by the model. And that gives us solid confidence that we haven't overtrained the model and that we haven't come up with an inaccurate model that seems good. So this is the comparison between FICO 9 and the DAI model. Now, obviously, before you start constructing models for consumer credit and power a credit card company, there is some domain understanding that needs to take place. But I think this gives you a good example of why a tool like this can really empower people to solve problems that have been very difficult, intractable problems in the past by taking a nonlinear approach to these problems. So here's an example of, we ran that DAI model against those 500,000 records with 222 attributes, and the runtime, I think, was about an hour. So you can solve very significant problems with many iterations of testing in a very short period of time. We try to keep our time to market for a new model within the 2-day range. So it's a very different dynamic for how you approach the iteration of models, to shift from models that iterate on an annual basis as a typical bank to models that can iterate in real time. One of the things we do at Underwrite is when we score a loan application for a lender, we return the probability of a profitable outcome. So we know that if we return a score of 0.99, that has a less than 1% probability of not being profitable. So we're continuously measuring the performance of our models at each stage of the repayment process to determine whether the model is in fact accurate. If we see a variance, if we see an indication that a 0.99 has a greater than 1% occurrence of loss, then the model retrains. So the models are fully dynamic and are never really finished. The model continuously learns from its own performance feedback. In a similar situation, we were approached by a lender in the UK who was extremely good at what they do. They're a subprime auto lender, and their repo rate is 3%, whereas in the U.S. it would typically be somewhere between 6 and 12% for similar credit quality. The problem that they had was, as good as their underwriting was, it took them between 2 and 3 days on average to underwrite a loan. They had 150 people working on underwriting loans, and they were producing about 100 decisions a day. The business was highly profitable and worked very well. But the problem is they had an opportunity to add 2 large online brokerages, which would give them an additional volume flow to take them from 100 loans a day to 1,100 loans a day. Well, you can't really address that problem by just increasing your workforce by a factor of 10. So they were kind of stuck not being able to take this additional volume. And they came to us and asked if we could not improve upon their process, but simply build an AI model that would reach the same conclusion as their human underwriter. But instead of it taking 2 to 3 days, could it take a millisecond? And so that's what we built, is essentially a fitness model that sought to get as close to the human underwriting decision as possible. So we created a gradient boosting model ensemble, which modeled on the decision of the underwriter, and then we got the underwriters to give us feedback. So when we released the first model, it had a fitness of about 85%. So in 85% of the cases, we reached the same conclusion as the human underwriter. So we then started working with the human underwriters to have them tell us, in that 15%, who was right. You know, why did they reach a different decision than our system did? And we evolved the model until it had a fitness in the high 90s, and that's where we are today. We then chained in a second model, and the inspiration of that was Google's AlphaGo model, which has 2 chain networks. So we created one network for matching the determination of the underwriter. We created another network to calculate the probability that the loan that the underwriter would approve would be profitable. And that chain is then serving as the methodology for approving loans. So we took them from processing 100 transactions a day with a staff of 150 to processing 1,100 transactions a day with a staff of 150. And I think that that's an example of the power of what machine learning can do to reduce latency and expand throughput in a lot of problems. This is a really clear case where we can build an AI system that works in conjunction with humans to create a super additive advantage of within the model. When I mentioned before that we had created a thin file model for consumers in North America, and it's called UC1, and it was just released at Lendit this past month. What we discovered in working with lenders is that if a lender had an overall loss rate of 10% on their portfolio, if that lender tested into their decline market and actually lent money to people without FICO scores, we would see a consistent 14% loss for people with no FICO scores versus the 10% average loss for people with FICO scores. And so the question was always, well, why don't lenders just loan to people without FICO scores at their highest tier rate? Because we saw the lender with a 10% charge-off had a tier where they expected losses of 24%. So they were profitably loaning with a 24% loss rate, but they weren't really loaning to people without FICO scores. So we knew it would be profitable for lenders to lend to thin file consumers, but we wanted to see if we could make things more granular. So for instance, could we tell a lender what portion of the thin file population would default at less than 2.5%? And we found very clearly, yes, that 30% of the thin file population will default at less than 2.5%. Another 20% will default at 6.46%. So if you take the average of those, you'll see that 50% of the thin file population will default at under 4.5%. Well, that basically means that 50% of people without FICO scores are prime borrowers. And what's interesting about that is that 50% of the overall market are prime borrowers, because the prime borrower is defined as being someone above 700 in FICO score. So you can see that this model allows lenders to apply the same risk standards to thin file consumers as they have for thick file consumers. And you can see that we've constructed these 5 grades which have a very nice slope to them. And so if a lender knows that they cannot make money with a higher charge-off rate in a tier of 24%, this model allows them to loan to 90% of the thin file population without exceeding their threshold. So in that case, if a lender wants to lend effectively across the entire population, all they really need to do is cut off the 10% that has an essentially 50% probability of charge-off and loss. So this is something that I consider really a game changer in credit, in that it puts thin file consumers on an even playing field with those who have FICO scores. So kind of to sum up, the key advantages of dynamic and nonlinear models are greater predictive accuracy, because they have the ability to model a much wider range of attributes than a traditional linear regression can do. We are deploying DAI models through the DAI REST server which is a Java application which we load into an endpoint, and it basically returns a decision to us from an existing model with a full explanation of the decision in terms of its variable weights, and it does so in 500,000 nanoseconds, or 1/2 of 1 millisecond. So we can deploy these models in an extraordinarily performant fashion. We have full explainability at the decision level. So it isn't good enough to simply explain how a model works at the level of the model itself. For any given decision, you need to be able to explain why the model chose to decline or approve this loan. And the REST server, through its explainability mechanism, gives us the ability to return that to the lender or to return to ourselves for processing into an adverse action notice, and still stay within our 1/2 millisecond delivery time. Another aspect of why lenders should move to nonlinear models, aside from the performance improvement and the greater accuracy, is to remove some of the remaining bias in the human underwriting program and the scorecards that are generated as a result of a human bias program. One of the things that we learned early on in doing this kind of work is that all humans bring bias into their process, right? I mean, we all have biases, and we all have preconceptions about variables. So one of the things that, when I first started this type of modeling, I realized is, well, I thought I knew what was predictive in a credit file. So in order to counteract that, I started taking out all the labels for the variables that we had in a credit report, and just labeling the variables A1 through A1250, and build the model without understanding what the attribute was. And by doing that, we found that many of the attributes that we thought logically that most people in this space think are predictive are actually not. And that many of the things that we didn't realize were predictive were. We don't do that anymore because we learned the lesson that you have to set your biases aside. But that's still a very prevalent issue in lending today. And by abstracting things out through a machine learning process, you get much further along to the elimination of bias in lending. When we build a model, we will not accept as an input to the vector anything that we consider to be a proxy for a protected class. So everyone knows that you cannot make a lending decision based upon ethnicity or race or gender or age. But one of the things that people don't take into account is that if you use zip code in your process, zip code is a proxy for race. And if you have any question about that, you can simply go and look at the fact that the Census Bureau has a list of minority-majority zip codes. So if you are using zip code within your underwriting process, you've created an inherent bias on race. If you use name in your process, you're extending bias to gender, ethnicity, and religion. So one of the advantages of taking a more rigorous machine learning approach is that we reduce everything to raw numeric variables. And we've pre-processed to make sure that there is nothing in the vector that would violate the anti-discrimination and fair lending laws. So that's, well, here, I'm going to bring that back up on the screen.
Thank you. Thank you, Mark.
You're welcome.
Excellent presentation, excellent overview. A couple of questions. So how big of a team did you have, Mark, while building all this together, right? So basically, it's a lot of work, right? I mean, the big challenge with machine learning is that you need expert data scientists who can do this for you, like especially if you're looking at like 16,000 variables, for example.
Right. Well, actually, I mean, that's where something like DAI comes in, because when I started working on these problems, you know, I didn't really, I had just sold my shares in the last startup I had done, and I had a little bit of money, and I was looking at what I was going to do next, and I decided to start this company. But I didn't want to run it as a conventional company. I didn't want to raise any investments. I wanted to just write it myself. I didn't want to really have to hire a lot of people and build a big company infrastructure. So I started writing the initial AutoML and started kind of grappling with these problems. Over time, I found that various bits and pieces of what I had originally written could be replaced with some of the tool set produced by H2O, including DAI. And so we've migrated much of the process of experimentation and training to use H2O tools. But the beauty of something like this is that with one data scientist, with an understanding of a domain, you can have an extremely productive model for developing nonlinear models. So we have, you know, people working at Underwrite, but I'm really the only data scientist involved. We have people, you know, who handle support and accounting and legal and compliance and all that good stuff. But basically the process of generating models is fully automated between what we've done in-house coupled with the use of DAI and a lot of hardware.
That's amazing. Yeah, I mean, that's a game changer, right? Because now you can basically build a really sophisticated model, basically competing with you know, other big FIs who are building these models themselves, and you're able to sort of leverage a gap that's in the market that's left out by people who are not going after the thin file folks, and be able to do that without having a large data science team.
Yeah, and the other aspect of it is that much of our focus is on underserved markets. So Underwrite provides credit underwriting right now throughout the United States, Canada, Mexico, the UK, the Philippines. We're going to Indonesia, and we are in the process of launching in South Korea. Also most of Latin America. So we're really focused on how can we build effective credit models of risk in markets that don't have credit models, and thus expand the availability of credit access throughout the developing world. And that, to me, is actually a much more critical mission for us than expanding credit access in the United States. There's a real problem with credit access in the United States. But when you look at countries like the Philippines, you know, we have a lender that we built there. 90% of the Philippines is unbanked. 97% of people in the Philippines have no access to formal credit. So the ability to deploy credit in the form of cash through convenience stores and using a mobile app all of which is empowered by the use of AI systems for both KYC and for underwriting. It's a huge game changer. And that's really much of what we're focused on. How can we allow lenders to deploy capital in markets that have been previously closed because of a lack of efficiency? And that is something that these kind of tools excel at.
That's very cool. The sort of second question I had, we touched upon it briefly, is around explainability, right? So how important is explainability? Because you are making decisions based on the prediction of the model, but understanding why a prediction is being made, especially for some of the folks who are the traditional FICO variables are not that useful, can be super important, right? So you do talk about some of the bias, like explaining bias, for example, like if you're using census data, for instance, and that could be a proxy for some of the other variables which you're not supposed to use. Yeah, just wanted to hear a little bit more about how important that is for you.
Yeah, well, it's absolutely essential, because when you are a consumer lender in the United States, the compliance with fair lending and compliance with the Fair Credit Reporting Act, these are not optional, right? They don't just apply to banks. They apply to anyone who's involved in fintech or lending. So you owe an individual who comes to you for money either an approval or a denial, and in the event of a denial, you need to explain to them in terms that they understand why you turn them down. And the reason for that, it's not really that the government defines a template for adverse action reports. The government does define a template. But the real reason is that if somebody comes to you and wants to borrow money and you're not going to loan it to them, you owe them an explanation of why. So if it's due to a behavior under their control, they can change it, right? So if somebody comes to me and I'm not going to loan them money because they have too many outstanding loans, I want to be able to tell them, we can't loan you this money because you have too many outstanding loans, but if you pay some of those off successfully and reapply, we may be able to loan money to you, right? So it's both not just an ethical obligation, but it's a smart business practice to explain to someone who can't be your customer today how they could be your customer tomorrow. And there is a need to explain exactly why you can't make a loan and how you might be able to remediate that. And that's exactly what we're getting back when we request an explanation through the DAI REST server. Now, it's not quite as simple as giving us a human-readable explanation. What it actually is the weights of all the variables that led to the model. But then one can rather simply create a matrix that says, oh, well, if we decline this loan because of the debt-to-income ratio, what are the variables within the credit file that caused the problem, right? So we can then look up in the credit file how much debt the person had, and we can give them a reasonable explanation. And the law requires you to provide up to 4 reasons for a decline, and you need to be able to tell them where the data came from. And in this case, the data came from the underlying credit file, and you give them the ability to receive communicate with the bureau, receive a free annual credit report, and if there is a problem with the credit report, give them a mechanism for remediating the problem with the bureau. So you see this in the United States. You also see it in a different form in Canada. In the EU, under GDPR, there's a new regulation which basically creates that the right of explainability is a basic human right in the European Union. So if you're using a computer program to make a decision, whether it's for lending or medical care or whatever, there is a right that the recipient of the decision has to have it explained to them. So black box lending and black box decisioning is really a thing of the past. It isn't good enough to say, well, we declined you because our program said that you were declined. It has to be a human understandable explanation. And that's just not an option anymore. And that gets into whether we can use deep learning models to make these kind of decisions, because convolutional networks are inherently so complex that it's very difficult to really unravel why a decision was made. And that's fine in the realm of visual problem solving. You don't really need to explain in an automated vehicle why you think something is a stop sign. You just need to stop. But in the case of the type of work that we do, black box models are just not going to fly.
So we are almost at the end of time. Thank you, Mark, for the wonderful talk and for answering the additional questions. There's a couple of questions on the chat, but we'll send responses to those offline. I want to thank everyone for dialing in today and listening to the whole talk. It was extremely informative. We'll send the slides over to folks who have registered and folks who are RSVP. And if you come back the same year, we'll see that.
All right.
Thank you, Mark, again,
once again.
Everyone have a good day. Thank you.